Everybody has heard of the speed of light, but did you know that light can travel slower depending on what material it's traveling through?
Light can also change direction when it enters a different material. This is called refraction, and it's how lenses, like the ones in eyeglasses, work.
Think about a marching band walking in nice even rows on pavement, but then part of the marching band starts walking through mud. The marchers walking in the mud walk slower than the marchers on the pavement, so the line bends. But that doesn't explain why we have a slab of gelatin here.
Well, to demonstrate, I made an experiment using this gelatin.
Cool!
I used lemon gelatin, so we can see a laser beam travel through it. And it's sugar-free, so it won't make a mess.
Good thinking. So where do we start?
First, cut a rectangle of gelatin using this ruler, so we have nice straight sides.
Okay.
On this paper, I drew 2 perpendicular lines. Put the rectangle on the paper with one side on one of the lines.
Got it. So where does the laser come in?
We're going to shine the laser along these other lines and mark where the light comes out of the gelatin.
I can see the laser beam in the gelatin, but why can't I see it in the air?
You can't see a laser beam unless there's something to scatter it to your eyes, like dust or smoke or this gelatin. Sorry, but there's really no lightsabers.
Hey, every time the beam bends so it makes a smaller angle in the gelatin than in the air. I wonder what would happen if we used a different shape. How about if we use a circular cookie cutter and make overlapping circles so it makes a convex lens?
Then take another rectangle and cut circles out of the sides to make a concave lens.
Let's see what happens with the convex lens.
Wow, the beams meet on the other side of the lens. I guess that's why they call it a converging lens.
How about the concave lens?
Hey, the beams separated this time.
I guess that's why they call that a diverging lens.
I wonder what would happen if we tried to make a fiber optic cable out of gelatin.
Cut a long strip of gelatin and arrange it however you want, and then shine the laser beam through it. What do you think will happen when the laser goes through the gelatin? I'm Emily.
And I'm Blaine.
And this was Exploring Refraction.